There's a lot of innovation happening in the space industry. In this video, we will take a look at some of the most promising rocket launch companies one should watch out for in 2024. These companies are working on relanding rockets, innovative technology where a rocket is accelerated on the ground to go to space, and cutting-edge 3D printing technology, which takes rocket manufacturing to another level. Also, we will take a look at starting companies which could make a big leap in 2024. And lastly, try to answer the big question if one of these companies can really compete with SpaceX in the future. First up, we have Ispace, also known as Beijing Interstellar Glory Space Technology, which is the first private Chinese company to achieve a successful orbital rocket launch, and is the only current rocket launch company besides SpaceX and Blue Origin who is at an advanced level in trying to reland rockets. Ispace's existing operational rocket is a 4-stage vehicle with a payload capability of 300 kilograms. First 3 stages utilize solid rocket motors, while the 4th stage is powered by a liquid rocket engine. Since the Hyperbola 1's first launch in 2018, there have been 5 successful launches and 3 unsuccessful ones. Presently, Ispace is developing the Hyperbola 3, a 2-stage rocket featuring methane and liquid oxygen engines, with the ability to transport a payload of 6.2 tons to low Earth orbit. The most important aspect of this rocket is its vertical landing capable. 2-op tests similar to SpaceX's initial Falcon 9 tests were conducted in 2023. The most substantial test reached a height of approximately 340 meters and covered a horizontal distance of 50 meters, marking a significant stride towards developing a relanding rocket. The first launch of the Hyperbola 3 is scheduled for 2025. With a current funding of $180 million and an operational rocket, Ispace is well positioned to complete the development of the relanding Hyperbola 3 rocket. Another company to keep track of is the American-based company Spinlaunch. Spinlaunch is focused on developing an innovative technology which could significantly lower the cost of payload. Their launch apparatus consists of a suborbital accelerator, which is a large vacuum chamber in which a rocket is accelerated by spinning. The expected speed of the rocket exiting the chamber is 2.1 kilometers per second. This start acceleration will propel the rocket to a height of 60 kilometers, where the liquid engine of the rocket will ignite to reach orbit. In 2022, Spinlaunch achieved an altitude of 10,000 meters, with a basic projectile carrying scientific payloads from NASA. According to the company, the first full-scale test flight propelling a rocket into orbit is planned for 2025. Similar to Ispace, Spinlaunch has secured substantial funding, totaling $150 million. Key investors in this backing include Google Ventures. Another more well-known company is Relativity Space, which was founded by 2 former SpaceX employees and is located in the United States. The company is centered around 3D printing, employing their in-house developed 3D printers to manufacture most of their tank structure and fully 3D print their engines. Besides advantages like manufacturing complex structures in one part, 3D printing also allows for short production time and automated process. Relativity Space initiated its rocket endeavors with the Terran 1, equipped with ion engines. These engines produce a sea-level thrust of 100 kilonewtons, utilizing a simple gas generator cycle, and are powered by methane and liquid oxygen. The Terran 1 was designed to carry a payload of 1,250 kilograms to low Earth orbit. However, a setback occurred in 2023 during a test flight, where a second stage failure prevented the Terran rocket from reaching orbit. In response to this, the company decided to progress to a larger rocket type, the Terran R, which is more suited to the current space market situation. Therefore, the current focus for Relativity Space is the development of the Terran R, which is anticipated to have a payload capability of 23.5 tons. Similar to the Falcon 9 rocket, the first stage of the Terran R will also be designed to reland. Powering the Terran R rocket is the Ion R engine, an evolved version of the Ion engine, producing a 10 times larger thrust of 1,150 kilonewtons. In addition to their emphasis on 3D printing technology, another factor contributing to Relativity Space's potential success as a rocket launching company is their substantial financial backing. The company has successfully raised over $1.2 billion, surpassing the funding of any other company on this list. According to the company's projections, The first launch of the Terran R is expected in 2026. The next company is not as innovative as the former ones, but has a really solid and conservative approach, which could potentially also be key to success. As Relativity Space, ABL Space Systems was founded by 2 former SpaceX employees and is located in the United States. ABL Space Systems is presently working on the development of the Astra rocket, designed to carry a payload of 1,350 kilograms to low Earth orbit. The installed E2 engines operate on a conventional gas generator cycle and are using RP1 and LOX propellants to provide a thrust of 180 kilonewtons. The only innovative feature of the Astra is that each stage is sized to fit in a standard shipping container, so that the stages can be transported by air, land or sea to a desired launch site, which enhances customer flexibility. The Astra rocket launched for the first time in 2023. A failure of the electronic system caused an explosion at the pad. An optimized version of the Astra will launch in the near future. I included this company due to its substantial financial backing of $400 million, which ensures the company's future stability. Lockheed Martin is one of the major investors. That suggests that the company's conservative approach aligns with the support from such an established manufacturer. The next interesting company on this list is Skyrora, which is located in the United Kingdom. Skyrora currently develops the 3-stage Skyrora XL rocket, which will be capable to deliver a 300 kilogram payload to low Earth orbit. The first and second stages are propelled by Skyforce engines, which are conventional gas generator cycle engines with a sea level thrust of 70 kilonewtons. The third stage engine is pressure-fed and reignitable. Besides the small set launcher, Skyrora also develops their own hybrid 3D printers called Skyprint. The 3D printer is called hybrid because a CNC mill is integrated into the 3D printer. The company claims that the 3D printer also allows for the printing of multi-composite parts, using material combination with inconel, titanium and aluminium, setting it apart from similar printers, even those used by Relativity Space. Skyrora also develops a process to convert unrecyclable plastic waste through a catalyst process to aerospace fuel called ecosene. In times of climate change, this is definitely an honorable goal, but the engine is only predicted to have a specific impulse of 250 seconds, which could be caused by the recycled fuel and may not be competitive. Despite having raised only $32 million to the state, the lowest capital among the previously listed companies, Skyrora shows potential for additional income sources with its own 3D printers and recycling processes. The company also has prior launch experience with operational sounding rockets. The first launch for the Skyrora XL is scheduled for 2024. The next company is Firefly Aerospace, which is a more well-known company in the aerospace industry. Firefly's Alpha rocket can deliver a payload of 1,030 kilograms to low Earth orbit. On its first stage, Reaver engines are installed, which are innovative tap-off cycle engines. In this cycle, hot gas from the combustion chamber drives the turbine, eliminating the need for a gas generator to power the turbine. This design makes the engine lightweight and simple. Also, it is the first ever successful flown tap-off cycle engine. It produces a thrust of 800 kilonewtons and uses liquid oxygen and RP1 as propellant. The second stage engine, named Lightning, also operates on the tap-off cycle and produces a thrust of 70 kilonewtons. The Alpha rocket has flown to the state 4 times, with 2 complete failures and 2 partial successes, where the intended orbit was not reached perfectly, causing early deorbiting of the satellite. Additionally, there are 5 launches planned for 2024. Firefly Aerospace has successfully secured $175 million in funding and currently has an operational rocket yielding returns on some of the investments made. This positions Firefly as a potentially successful company in the future. Similar to Firefly Aerospace, Astra is also a more established company in the United States. Astra's Rocket 4 has a capacity to deliver a payload of 600 kilograms to low Earth orbit. The first and second stage engines operate on a conventional gas generator cycle. The company has conducted a total of 9 rocket launches, with 5 failures, 2 partially successful suborbital launches, and 2 successful launches. Additionally, there are launches planned for 2024. Astra has successfully secured a substantial amount of funding, totaling $325 million. With an operational rocket already in place, Astra is in a favorable position as it looks toward the upcoming years. The next company on this list is the in Germany located rocket factory Augsburg, short RFA. Its proposed rocket is the RFR-1 with a 1,300 kg payload capability to low Earth orbit. The rocket is propelled by helix engines, utilizing a complex staged combustion cycle to enhance efficiency. It is predominantly additively manufactured and employs RP1 and liquid oxygen as propellants. The company successfully conducted an engine hot fire test, demonstrating a complete flight duration of 280 seconds. Another interesting aspect of this company is its association with OHB, a large satellite producer based in Germany. OHB, with a current revenue of 1.1 billion, provides financial support to RFA. This partnership ensures the financial stability of RFA, and OHB has a substantial number of satellite launch contracts to offer to RFA. The first launch of RFA is scheduled for 2024. Another launch company located in Germany is Isar Aerospace. Its Spectrum rocket can deliver a payload of 1,000 kg to low Earth orbit. The rocket is propelled by the mostly 3D printed Aquila engine, which operates with RP1 and liquid oxygen in a conventional gas generator cycle. In 2023, the company achieved 124 successful hot fire tests of the engine. Isar Aerospace too has raised a substantial amount of funding, totaling around $165 million. The first launch is scheduled for 2024. The last company on this list is Orbex. It has its headquarters in Scotland and its engine production in Denmark. The two-stage launcher Orbex Prime will deliver a payload of 180 kg to low Earth orbit. The launcher is powered by Orbex 3D engines, which will be 3D printed in a single piece, which increases production efficiency. The engine uses liquid oxygen and biopropane as propellants, which cuts the emission by 90% when compared to RP1 and liquid oxygen. The company has raised to this date 69 million in funding. The first launch is planned for 2024. Now we have taken a close look at all companies. In my opinion, the most likely company which will be able to compete with SpaceX is Relativity Space. It has the best financial backing, already manufactures rockets for 3D printing, what will be one of the most important manufacturing technologies in the future, and it plans to build a rocket which relands, and will try to a company which will be probably able to compete with SpaceX is Ispace, because they are already in the development phase of a relanding rocket. With that said, there's the probability that SpaceX will pull off the development of the Starship before any of the companies succeed, and therefore will receive all launching contracts because of their cheap price. This would make the business case of all companies on this list not existing.